we have finished most of the theory regarding definite integrals. Today we are going to learn miscellaneous examples which will help you in solving complicated problems of competitive exams. Let us take an example on area. So, the area is defined by a set in Cartesian plane for x minus 1. So, the first step to solve this problem is we need to identify the region. So, let us first find out what is represented by y square is less than or equal to 2x. To realize that, we have to plot first this equation, which you know it is a parabola whose vertex is 0 0 and axis is x axis. So, you get this is y square equals to 2x. Now, we need to find out which region is represented by y square less than or equal to 2x. So, if you take any point outside the parabola, maybe here, here, here or here. So, let us take 0 comma 1 and see. So, if x is 0, you get 0 into 2, that is 0, and this side LHS you get 1, which is strictly 1 is strictly greater than 0. So, the inequality is not satisfied. Similarly, you can check it for this point. Say this point is minus 1 comma 0. So, 2x will be minus 2 and y square will be 0 at minus 1 comma 0. So, again you can see that the inequality that you get is this. Similarly, for this point also. So, if you take any point above parabola or on the negative side of x axis or below this parabola, so all these points are outside the region. So, if you take any point inside the parabola, you see that this inequality will be satisfied, y square is less than or equal to 2x. So, y square less than or equal to 2x is this shaded area. So, this shaded area is y square less than or equal to 2x. Let us see what region is represented by y square greater than or equal to 4x minus 1. So, for that we have to plot first the line y equals to 4x minus 1. So, let us plot y equals to 4x minus 1, and then we try to realize what is this region y equals to y greater than or equal to 4x minus 1. So, for that first let us plot the line x y. This is 1 by 4 comma 0, and if x is 0, y is minus 1. So, this is 0 comma minus 1. So, this is the line y equals to 4x minus 1. Now, if you take any point above x axis, say on y axis, above x axis on y axis. So, this is 0 comma 1. So, 4x minus 1 will be minus 1 and y is 1. So, 1 is greater than minus 1. So, the inequality is true. Now, if you take any point below this line, say you take 0 comma minus 2. So, x 0 4x minus 1 at x equals to 0 is again minus 1 and y is minus 2. So, minus 2 is lesser than minus 1. So, the inequality is not satisfied. So, if you take any point above this line, that means this region, the inequality is satisfied. So, this y greater than or equal to 4x minus 1 is this red, y greater than or equal to 4x minus 1 is this shaded area. Now, let us plot both the curves on one Cartesian plane, so that we can realize which area we are supposed to compute. So, we need to now draw y square equals to 2x and y equals to 4x minus 1 on one Cartesian plane. So, y square equals to 2x is this and y equals to 4x minus 1 is this. So, your y square less than or equal to 2x is area shaded by green color and y greater than or equal to 4x minus 1 is area shaded by red color. So, the common area that is satisfied by both the inequalities is this area. So, we are supposed to find out this area. For that, we need to find out the point of intersection of both the curves. So, we need to solve both the curves. So, y equals to 4 y square equals to 2x, 4x is y square by 2 minus 1 . So, y values will be so we get 1 and minus 1 by 2. So, this is y equals to minus half and this is y equals to 1. So, the area required, if you integrate in the direction of y, so you have to divide this area by small thin strips, horizontal strips. So, if say this is dy, width of one strip, so length of the strip will be y value from this line minus y value from parabola. So, length of the strip is y plus 1 by 4 minus y square by 2, this is the length, and dy is the width. So, this is your elementary area, and if you integrate it from minus half to 1, you get the required area. So, let us integrate this to find out the final required area. So this is 1 by 4 this is equal to we get minus 9 by 32. So this is your final answer. Now let us take another example. We need to find out the area enclosed by so find out area enclosed by above two curves and the lines x equals to 0 and x equals to pi by 2. So let us plot y equals to sin x plus cos x first. So you just try to find out, see what is the value of y0. Y0 is 1, y pi by 2 is also 1, and if you find out the derivative you see that it is cos x minus sin x. So to find out whether it is y dash is positive or negative, we need to just, this is a rough work, not actual plot. So you need to plot cos and sin both is pi by 4. So graph of sin x from 0 to x equals to 0, from 0 to pi by 2 is this, and graph of cos x, the plot will be like this. So the values, they have same values at pi by 4. So you can see that this is cos x and this one is sin x, black one is sin x and red one is cos x. So you can see that cos x dominates sin x between 0 and pi by 4. So this will be positive in this interval, and y dash will be y dash, that means y dash is this. So y dash will be negative when sin x dominates cos x. So this will be negative in this interval. And y dash at pi by 4 is 0. So the plot of is pi by 4, is pi by 2, this is 0. If this is 1 unit on y axis, so at 0 the value is 1, at 0 the value of this is 1, and at pi by 2 the value is 1, and at pi by 4 y value is 1 by root 2, 1 by root 2, 2 by root 2, that is root 2, which is greater than 1. And so somewhere here, if I represent root 2, this is root 2 say, so y is increasing, y dash is positive from 0 to 4, so y is increasing, so we will get this curve, and at pi by 4 it is 0, so the horizontal line which passes through pi by 4 comma root 2 will be tangent, and after that, since y dash is less than 0, the curve will be decreasing at it reach here. So you have this shape of y equals to sin x plus cos x, we get this shape, Let us plot this curve also on a separate Cartesian plane, then we will combine it. Let us plot y equals to cos x minus sin x on a separate Cartesian plane. So let us plot cos and sin again, because we need to refer that. This is pi by 4, this is pi by 2, this is 0. So cos 0 is 1, cos pi by 4 is 1 by root 2, cos pi by 2 is 0. So this is cos x, and say this is your sin x, this is your sin x. So this is sin x, this is cos x. Since modulus is there, to open this we need to know where cos x dominates sin x and where sin x dominates cos x. So y dash is cos x minus sin x, because cos x dominates sin x in the interval 0 to pi by 4, and if you compute y dash you get sin x minus cos x, because sin and cos both are positive, so this will be negative in this interval. Similarly, for the other interval, that means from pi by 4 to pi by 2, y is minus of, because sin x dominates cos x, so we get minus of cos x minus sin x, and y dash will be sin x plus cos x, which is always positive in this interval. So how this curve will look like, at y is 0 it is again 1, at y by 4 it is 0, and at y pi by 2 it is from, you can put the values of x here and see what is y. So y pi by 2 it is again 1. So if this is x equals to 0, this is x equals to pi by 2, and this is x equals to pi by 4. So from 0 to pi by 4, y dash is negative, so y is decreasing, and y value at 0 is 1. So and pi by 4 it is 0, so it is decreasing, y is decreasing because y dash is less than 0. From pi by 4 to pi by 2, y dash is positive, so it is increasing, and pi by 4 it is 0 and pi by 2 it is 1, so you get this curve. Now let us plot both the curves on a single Cartesian plane, so that we can realize what is the area. So y equals to sin x plus cos x, and y equals to mod of cos x minus sin x. This is y axis, this is x axis, this is this is 1 unit, this is pi by 4 is 0, this is pi by 2. So, and this is somewhere is this is root 2. So, sin x plus cos x is this curve we have seen, and mod of cos x minus sin x is this curve. So, this is drawn by black color and this one is drawn by blue color. So, the required area is this is your required area. So, to find out this area we need to break it in two parts, because if you draw vertical strips, thin rectangles say of dx width, so you can see that for this portion which lies between 0 and pi by 4, it starts from one curve and it finishes on y equals to sin x plus cos x, and for this portion it starts with another portion of the curve which is governed by different equation. So, we need to break it in two parts. So, total area required will be elementary area from 0 to pi by 4. So, elementary area is sin x plus cos x minus this, which is cos x minus sin x dx, plus from pi by 4 to pi by 2 dx. Elementary area is this into dx, and what is this is sin x plus cos x minus this equation of this curve is minus of minus cos x plus sin x. So, we get 0 to pi by 4 2 sin x dx plus pi by 4 to pi by 2 2 cos x dx. Let us integrate it. Okay. So, you got this, the integration of this is minus cos x 0 to pi by 4 plus integration of this is sin x pi by 4 to pi by 2. We get by putting the upper and lower limits, we get upper limit is this and lower limit will give you 1 by root 2. So, total value is 4 times 1 minus 1 by root 2. So, required area is 4 times 1 minus 1 by root 2. So, there is one important point to notice in this example. If you see the region, this region can be divided into two portions, and this region which I have shaded now even with blue color and this one by green. So, they are symmetrical. So, instead of computing both the areas separately, you can just compute this and twice of this will give you the required area. Fine. So, let us take another example. Find all possible values of b so that area of the bounded region enclosed between parabolas y equals to x minus bx square and y equals to x square by b is maximum, where it is given that b is positive. So you can see that this is a very simple curve. Y equals to 1 by b square is a parabola whose vertex is 0 and axis is y axis, y equals to 1 by b x square. So b is since b is positive, if b is negative it would have been inverted. So this is the parabola. Let us plot y equals to x minus bx square. This we can write as minus b. If we take common, we get x square minus x by b, which we can write as plus 1 by minus 1 by 4b square. So therefore this can be written as plus 1 by 4b. So y minus 1 by 4b is equal to minus b x minus 1 by 2b is this. So this equation is of this kind, b is positive. So this parabola is inverted, whose vertex is at 1 by 2b comma 1 by 4b, and it passes through, you can see that x equals to 0, y equals to 0 and x equals to 1 by b, y is 0. So this is inverted parabola whose axis is x equals to 2 by b and vertex is 1 by 2b, 1 by 4b. Now let us plot both the parabolas on a single Cartesian plane. This is your y equals to x square by b, and the other one is this. So your area that is enclosed between them is this one. So, we need to find out this point of intersection of both. So, let us solve both the equations. So, we get x. So, x is therefore 0. If you solve this, you get x equals to 0 and x equals to b by 1 plus b square. So, this is x equals to b by 1 plus b square. So, the area required is elementary area. So, elementary area is x minus bx square minus x square by b into dx. X goes from 0 to b by 1 plus b square. Let us integrate this. So, required area x square by 2 minus b by 3x cube minus x cube by 3b 0 to b upon 1 plus b square. This is equal to b square by 2 minus whole cube minus b cube by 3 b 1 plus b square cube minus this is b square. So, if we take common plus b square cube, we get b square upon 1 by 3 1 plus b square cube, b square by 1 plus 1 by b square by 3 into 1 plus b square cube is common. So, we get 1 plus b square. So, value of this is required area is b square by 2 into 1 plus b square minus this cubic will be cancelled and by this one. So, you get square here. So, b square on 3 plus b square square, this is equal to (3 minus 2 by 6 b square upon 1 plus b square square. So, required area is b square by 6 1 plus b square by whole square. So, we have computed the required area. Now, the question says that find for which value of b the area is maximum. So, let us compute that. So, your area is b square by 1 plus b square square 1 by 6. So B is positive, it is given. So for which value of B area is maximum? For that, let us differentiate this. We get this by applying rules of differentiation. So 1 plus b square is common here. So what we get is 2b plus 2b cube minus 4b cube. So we get 1 by 6, 1 upon 1 plus b square power 4, 2b minus 2b cube. So finally we get 1 by 3 b 1 minus b square by 1 plus b square. This is cancelled, it is cubic, not 4 cube. So we have got dA by dB as 1 by 3 b 1 minus b square on 1 plus b square cubic. Now dA by dB equals to 0 will give you the required points where this can be maximum or minimum. So we get b equals to 0, b equals to minus 1, b equals to plus 1. So these two values we have to ignore because b is positive. So the only possible value that is allowed is of b, that at which we are supposed to compute maximum minima is b equals to 1. Now how to find out maximum minima? So we are not going to find out the double derivative. Let us see how to find out where the whether the area is maximum or minimum at b equals to 1. So dA by dB is 1 by 3 b 1 minus b square by 1 plus b square cubic. So and you can see that if b is greater than 1, then dA by dB is negative, and once b is less than 1, between 0 and 1, dA by dB is positive. So A increases when b increases and A decreases when A takes value greater than 1. So if you plot this around b, if this is the area, you plot the area. So b is 1, this is b. So when b is greater than 1, dA by dB is less than 0, so this is decreasing, and when b is less than 1, it is increasing. So at b equals to 1, area is maximum. With this we finish some examples on area. Let us see some more examples on definite integrals, miscellaneous from different competitive exams. This is the problem. It seems to be a very complicated problem on definite integrals, but if you apply certain properties of definite integral, it becomes very simple. So we know that x log m power n is n log m, so we get this. Here you can write this as 6 minus x whole square. So this will give us and 2 gets cancelled. We get, so finally we got this integral, and see that we are going to use this property of definite integral, which says that this value is equal to a plus b minus x dx. This value of the integral is same as this value. Now apply this, so you get 2 to 4 log of a is 2, b is 4, so you get 6 minus x dx by log x will be replaced by 6 minus x plus log 6 minus x. So I is therefore 2 to 4 log 6 minus x dx by log 6 minus x plus log x. So this, you can see that this, if you say this is 1 and you say this is 2, so both represents our initial integral, and if we add it, the integrand will become 1, because numerator will be log x plus log 6 minus x and denominator will be log x plus log 6 minus x, so both will get cancelled. So we will add it and we get 2i equals to 2 to 4 log x plus log 6 minus x by log x plus log 6 minus x dx, and this will get cancelled, so we get dx, which is 4 minus 2 is 2. So value of I is therefore 1. Now let us take another example. X square plus log pi minus x by pi plus x cos x dx. So let us break it in two parts. Log pi minus x by pi plus x into cos x dx is equal to, so since this integral is of the kind minus a to a fx dx, so we need to find out whether it is even or odd function. So this function is even function because if you replace x by minus x, you get x square, and cos of minus x is cos x, so you get twice of 0 to pi by 2 x square cos x dx. And if you see this function, if you put minus x here, you get pi plus x by pi minus x as cos of minus x. So cos of minus x will be cos x, and here you will get plus and minus if you put, and by using the property of log, you will see that you get a minus sign. If you replace x by minus x throughout this integrand, you get a minus sign outside. So this is an odd function. Therefore, by using the property of the definite integrals, you will get 0. So to see it carefully, let us do that. So you want to find out whether it is even or odd. So if this is hx, So h of minus x is log of pi plus x by pi minus x cos of minus x. By using the property of cos x and log, this can be written as cos x, which is, so this is an odd function, therefore minus pi by 2 to pi by 2 hx dx will be 0. So your integral becomes, finally you got this expression which is your value of the original integral, twice of x square cos x dx. This will be equal to, so you need to integrate it by parts. First function, this is second function. First function, integral of second is sin x. This is 0. So twice of 0 to pi by 2 we got. So first function into integral of second, 0 to pi by 2 minus 0 to pi by 2 2x sin x dx 2 pi by 4 minus 0 minus first function into integral of second is minus cos x 0 to pi by 2 minus minus plus 0 to pi by 2, differential of first is 2 and minus cos x dx. So this will be 0 at pi by 2, cos pi by 2 is 0 at 0, this is 0 because of this. So you get 2 pi by 4 minus 2 integral of cos x is sin x. So you get 0 to pi by 2, this is 2 pi by 4 minus 2. So the final answer is I have missed here one pi square, you get pi square. So final answer is pi square by 2 minus 4. Let us take another example. Under root log under root log 2 to under root log 3 x sin x square by sin x square plus sin log 6 minus x square dx. So since you see that x square is there and x is here in the integrand, so if we take x square equals to t, that will ease our computation and limits will be freed from square. So immediately you get x is, if you put x is under root log 2, you get log 2 as value of t, and upper limit will be t equals to log 3. 2x dx will be dt. So this x you can combine with dx, it will replace by half dt. Sin x square is sin t by sin t plus sin of log 6 minus t. So your integral is 1 by 2 I, say it is I is log 2 log 3 sin t dt by sin t plus sin log 6 minus t, log 6 minus t. Now by applying the properties of definite integral, which says that a to b fx dx is same as a to b f a plus b minus x dx. So we get log 2 to log 3 sine of ln 2 plus ln 3 will be ln 6. So, log 2 plus log 3 will be log 6. So, log 6 minus t dt by sine 6 sine log 6 minus t plus here t is replaced by log 6 minus t. So, you will get sine t from this term. So, you can see that if you add these two integrals, so numerator and denominator will be same, so they get cancelled. So, you get sine t plus sine log 6 minus t by sine log 6 minus t plus sine t dt. So, this get cancelled and you get 2I equals to 1 by 2 log 2 was missing here, log 3 dt, this is equal to 1 by 2 log 3 minus log 2, which is equal to so therefore I is 1 by 4 log 3 by 2. We have seen certain miscellaneous examples on definite integrals, on area and definite other kind of definite integrals. So, in our next class we shall continue with miscellaneous examples and see how to approach such complicated problems. Thank you.